Geography and You presents.
Welcome to this special episode of GNY Live, where we explore how science is pushing the boundaries of our understanding of weather and climate. I'm your host, Hiteshika, and today we turn to a subject that has captured both public imagination and policy attention: cloud seeding. Across the world, governments have experimented with weather modification to tackle droughts, enhance snowfall, and even disperse fog. In India, the subject has recently returned to headlines, with Delhi announcing its first pilot cloud seeding trials scheduled during the retreating monsoon. The proposal reflects growing interest in whether artificial rain can help wash away the city's toxic smog, even as experts debate its feasibility in Delhi's dry winter conditions. This raises pressing questions. How much of cloud seeding's promise is grounded in science, and how much remains a technological aspiration? Can engineered rainfall meaningfully address urban air pollution, or is its potential limited to water resource management? To guide us through these questions, we are honored to be joined by Dr. Thara Prabhakaran, scientist at the Indian Institute of Tropical Meteorology in Pune. With decades of pioneering work on cloud microphysics, boundary layer meteorology, and weather modification, Dr. Prabhakaran has led India's landmark cloud aerosol interaction and precipitation enhancement experiment, one of the most ambitious efforts to evaluate cloud seeding under Indian conditions. Her research continues to shape how the country understands atmospheric processes and their role in adaptation strategies. Joining this important dialogue is our discussant, Dr. Sulagna Chattopadhyay, Editor in Chief of Geography in You, a science communicator and policy expert who has worked extensively on climate change, environment, and governance. With that, I now hand over the conversation to Dr. Chattopadhyay.
Thank you, Hiteshika, and a very warm welcome to Dr. Tara.
Hello.
So today we have a very exciting discussion, really. This is about, in the winters, we are going to see a lot of pollution every year. Delhi sees this massive amount of pollution, and recently we have learned that cloud seeding, so if a cloud is the soil and you put seeds on it, the rain is what grows out of it and falls to the ground, and it's very exciting that apparently it can mitigate pollution in Delhi, really, in those really, really bad times. So Dr. Thara, do you think that's a possibility?
Yeah, first of all, for cloud seeding, clouds have to be present. Suitable clouds have to be present. And the point is that in winter conditions prevailing over Delhi, we have very dry layers above the boundary layer, which is indeed not very supportive for our processes that we are looking into. So, basically, I would say that it is not a very suitable solution if we think about cloud seeding as a way to improve the air quality during winter. But we can discuss further on other viable aspects.
Yeah, the Dr. Thara's hard no. We start with that. But before we move, Dr. Thara, if you can just tell us a little bit about what is this cloud seeding about actually? What do we do? As far as I am aware that we already have nuclei in the atmosphere. We already have aerosols around which the raindrops coalesce. So what are we now doing? What is the additional thing we do?
Yeah, actually, cloud seeding is nothing but introducing additional aerosol particles which can act as cloud condensation nuclei or ice nuclei particle in the clouds. The clouds have both water droplets as well as ice particles. So in case of clouds having majorly water droplets, we use hygroscopic, that is the particles that can attract water vapor from the atmosphere and condense and form more cloud droplets, or kickstart rain, through the collision coalescence mechanism in the clouds. But in the case of ice clouds, we are using particles such as silver iodide, where the silver iodide is used to make ice particles in the clouds, like deposit the vapor in the to form ice particles in the cloud. Actually, forming ice in the cloud is a much complex mechanism. However, in our kind of environments, like in warm tropical environments, we have hygroscopic seeding is also tried because that is having importance, because we have warm clouds, but they grow into colder regions in there. But there are also cold clouds. But the point is that we have to indeed look at what type of clouds are present and what kind of conditions are available in order to even choose what type of seeding to be done. So it's not a very straightforward process. It should be science driven. That is the point.
Absolutely. So what you're saying, doctor, is about, so basically these clouds, if you consider them, so they're different kinds of soil, say. So different
Yeah.
soils give different kinds of productivity.
Yes.
So different
Yes.
clouds give different kinds of productivity.
Yes. Yes.
And so if I may ask you, what about seeding? I mean, do we seed only for pollution, or is there other needs? Can we,
Yeah.
for example, have a cyclone cloud, which is, the precipitation is taken off so that it is not so vicious any longer, or maybe in the glaciers, climate change, and to mitigate climate change impact, can we have more ice on the glaciers as precipitation? So what other uses of cloud seeding is there?
Yeah, actually, the primary use, it is for the unconventional resource for water. Actually, that is by seeding clouds, whether we can enhance rainfall. That is the in water limited areas, such as in the rain shadow regions. We have conducted the CAIPEEX experiment over the rain shadow region, and which is see there in, for example, in the city Sholapur, we get only 3 days, once in 3 days they get water supply. Okay. Once in 3 days. So that is like because there is significant scarcity of water in certain periods, even though the monsoon is very active in several places in the country, but it is not uniform everywhere. There can be regions where there is significant drought conditions observed. So the question is, are there clouds that can be considered to tap the water? And whether it is a feasibility, because whenever there is a drought condition, the state governments will be thinking about whether cloud seeding can be done. But how much it is feasible, whether what kind of clouds to go after? You rightly said, whether all these clouds are giving the same amount of water. No, there are specific type of clouds to be targeted in order to and also under specific conditions only they could make some additional rain. So we have indeed conducted the CAIPEEX campaign and made a specific protocol based on which we can indeed give certain guidance and how to do such an experiment, how what kind of conditions to be considered. Actually, it is there is a significant importance for the observational strategies for this, to plan the experiments or to plan the operational seeding, etc. And considering, see, you were asking about cyclone or in other
Glacial
situations.
regions,
Yeah,
yeah.
yeah. Yeah, in the US, for example, they have considered cloud seeding for the snowpack, because in those places, snow enhancement, snow is also a form of precipitation. Snow enhancement is considered, and it seems to work in their area. There are very documented results on that. A scientific strategy has been followed. So similarly, we have in our country, we have followed the similar strategy with the CAIPEEX for the scientific strategy to prove what exactly is going on after seeding. So there are like investigations done, but in case of a cyclone, for example, it's a huge system. It is not recommended to do a cloud seeding per se on such a system. We still don't understand the complexities associated with such a system. And you see, whatever we have been doing is for single convective clouds. Okay, with the CAIPEEX, we have been addressing the convective clouds, not in any huge systems like a cyclone. But we are advancing with the numerical modeling as well, observational technology and numerical modeling, to understand the details of these cyclones, and we can predict them better, how they are going to evolve, etc. So also we are understanding certain processes that are associated with the cyclones evolution, and also so it is possible to at least simulate and see what happens in a numerical point of view. What will happen if we do seeding in such scenarios? So that is very much key for our any further means investigations what we need to do. Thank you.
Yeah. So wonderful. Now, just to understand a little better, if you see the cloud, do you know where the rain is going to be there? Where it will fall, where the rain will fall or the snow will fall? One. And if nothing happens, if there is no rainfall, what happens to that additional material that you put on the clouds?
Yeah, both are very important questions. How do we know whether that was the question that we have addressed in CAIPEEX? Okay, that is for this, we need to document everything. We need to have a hypothesis. Once we put the seeding in the apply the seed material in the cloud, what will happen? Can we follow the hypothesis? See, for example, when we do seeding, whether there are larger drops of liquid formed in the cloud or not, whether it is falling down, or whether it is falling down to the surface as whether it is reaching the surface as rainfall. We have to track that entire process. For that, we use aircraft, we use radar, which will tell us about the vertical structure and the horizontal span of the clouds and its movement, how it is going to go. And also on the surface, we have rain gauges, which will record how much of rain is falling in that area. Okay, radar also will give an aerial assessment of the rainfall. But it's very important to document all these processes, what we have considered in our hypothesis. Okay, if we do this particular seeding with this amount of seed material, it will indeed make this kind of changes. Say it will make large drops, and we have to document that process. So then only we are able to, that's what we have done in CAIPEEX. It has been a complex experiment. So for imagining, it's a very interesting things, but to conduct such experiment and to like even evaluation is a complex process. So we have adopted a randomized seeding process where some clouds were seeded, some were not seeded, based just like in medicine trials and all. So we are giving seed material to certain clouds, the
In the
other ones are
same area.
same area,
Okay.
but in different conditions, different environmental conditions. So we to span 2 years of monsoon seasons.
Okay.
So we had a bad monsoon, good monsoon, or above average and below average rainfall in the area. So we from that we have constructed some 267 samples of seeded or non-seeded clouds, and after that only, with that only, we have come up with a certain. We found 18% enhancement in rainfall in 100 square kilometer area.
Oh,
Yeah, that
that
was
18% is a lot.
yeah, that is a lot from one cloud. Okay, so and your next question was regarding
What happens to
what
the
happens if the cloud is not rained, and then that materials, of course there could be the material staying in the environment, but it will eventually fall out. But also, if a cloud is dissipating, also it is shedding a lot of water vapor into the atmosphere, possibly. And in our conditions, there is constant supply of moisture from Arabian Sea coming over to the rain shadow region in that altitudes that we are working in. So there has been occasions when the cloud is further invigorating in the downwind areas of the seeded location. So we have seen that it is not only at the location that it has rained. In some instances, few clouds indeed rained downwind of the seeded location. So that indeed brings something called an extra area effect. Okay, so which is quite important in the monsoons, where we have a strong low-level jet, which indeed pushes things further than the area that we are interested in. Yeah.
So, so if we can, I want to ask you about the cost, but before we go to the cost, there is also some people who have brought that there can be a certain detrimental impact on the environment because of these aerosols that you put up in the sky. So, what is your take, Dr. Tara?
Yeah, actually, this detrimental aspects that have been discussed is regarding the silver iodide that is used as the ice nuclei in the cold clouds. We call it as glaciogenic seeding. So in the cold clouds, silver iodide is used. In the warm clouds, calcium chloride is used. So calcium chloride is a salt, like
Like NaCl.
NaCl, like NaCl. So what happens is this silver iodide, it is even in small quantities, it is detrimental for the marine. Means all the aquatic systems and all, fish and other. So but it is there are no documented evidence from cloud seeding that it increases the silver content in the only in certain situations there are continuous seeding from the ground based burning systems. In the US, they have documented that near to the seeding area there has been effects, but other than that, so far in my knowledge, there are no documented evidence that this has caused actually, we, as part of the WMO peer review report, actually we have documented overall what has happened in the rain enhancement field. So in that we have not found such a documentation, but yeah, nearby there are areas when means nearby there are effects that are very much linked to the cloud seeding.
Yeah, so basically
Effect.
the chemicals in the sky is not to be afraid of as of now.
Yeah.
And you have seen experiments. But you mentioned US. Which other country has done a lot of cloud seeding experiments?
Yeah, there is a lot of work going on in the UAE and now Saudi Arabia, China, then Korea, as well as Australia. Now there is also something, the more work on the cloud brightening experiments going on to means understand the marine cloud brightening in order to understand the radiative aspects as well. These are all in very what to say the research on a research
What
basis,
is
which
cloud brightening? I mean,
actually it is to reflect more radiation back so that the whether we can look at the cooling impact of due to the clouds whether by seeding indeed we will reduce we will increase the number of cloud droplets in the cloud, so which will it will be many cloud droplets, so it will indeed reflect more radiation back. It will not rain out so quickly, so that way there will be a less radiation reaching to the surface, and then there will be a cooling effect, and something like that. It's a marine cloud brightening in certain parts of the world. Such experiments are in Australia. There are experiments conducted like that, and
India
also.
hasn't done any cloud brightening
No,
as such.
India has not done. That is something we are interested to look, but it would take some time. It's not a. See, we need a lot of technology advances in terms and observational facilities such as aircraft and now anyway the seeding with the help of drones or UAVs is one thing that is coming up, and also there are technologies used with the balloons. The various ways things are being investigated, but we have to on a research point of view we have to investigate that and see whether it is applicable in our conditions, and it will take a little bit of time, but we are on our way. In the recent mission Mausam that is established, we have a very dedicated vertical on the weather modification aspects, and under that we have established a center for the cloud physics and weather modification research. So under that we are indeed establishing various capabilities, including a cloud chamber. A physical cloud chamber, in order to study a convective cloud process. A convective cloud, we will be generating such a system inside a chamber, a
Oh
convection
my,
chamber. Yeah.
that is
So
very interesting.
that is actually we are planning that, and we are hoping that in another 2 years' time we will be establishing that facility, which will be a national facility situated in IITM Pune. And also we plan to do say various investigations or various technologies. So we want to test what could be, for example, you were talking about the pollution, air pollution, whether we can look for some other viable solutions. Currently I don't have something to suggest, but yeah, I think something we can investigate. Of course, the best solution is pollute less, and
Yes.
yeah.
So,
Uh,
if I may come back to our original question about IIT Kanpur's experiment in Delhi, so that will be my last question to you: is what is the cost of the experiment? We know it's about three odd crores for the the winter experiment, but in a typical experiment that you conduct, what is the cost? And you say that in Delhi it will not be successful. So, do you think that there is an alternative method, or do you think we should do this experiment in Delhi at all during winter.
Yeah, what I understand is the current experiment that is planned, it is an exploratory experiment. So possibly to see what works, etc. So, but we need to have more observations in order to support our hypothesis, we have to have a hypothesis to do any of these aspects. So, and that hypothesis has to be proved with the help of observations and various efforts that around surrounding that. So the cost
So
involved.
if I just come back once, just a little intervention here. So if a rocket or it's a flight, then is it one sortie, or do you have to take several sorties on top of the cloud? What do you physically need to do, and
Yeah,
then you
yeah.
can tell us that per seeding. What is
See, the main problem is no two clouds are same. They are so different, and so you have to indeed find a criteria to select the cloud.
Okay.
Okay, with the common criteria. That is what we have done in CAIPEEX. So a common criteria to select the cloud and only target such clouds, that clouds which is satisfying that criteria. So it is important to make certain line there. Okay, this is what we are going to do, and then the experiment is it's not very cheap. It is quite expensive to fly aircraft, getting all the permissions, getting all the crew, and getting all necessary things done. And in our case, we estimated around 15 lakhs per sortie, like that in our
15 lakhs. And what is the
yeah.
grid of that? How much area?
Yeah, it is. We were flying almost 3.5 hours, so per day, and that means, and that too within 100 by 100 kilometer area, 100 kilometer square area, and the point is. It's not like like we will be going into the cloud at different altitudes. So it is to register the complete vertical structure of the cloud, how that cloud is constructed. So we will be spending at least half an hour per cloud. So
you've been on these aircrafts?
Yes, I have done many, many. So it's very challenging, but at the same time, very interesting thing to like what you see in the textbook. It is in front of you. So it's like that. So it is very exciting as a cloud physicist to see all these
In real time,
things
in
that
front
are
of
real
you.
time. Yeah, in front of us. Sometimes we are even running numerical models, forecasting, and then going there and seeing, okay, this is the kind of cloud that we have forecasted. So if you are seeing the same type of characteristics, it's a very, very fulfilling experience, right? And we have learned a lot with so many of along with many of my colleagues. So much we have learned regarding the cloud microstructure over the region, which has been the guiding principle for us to conduct a successful CAIPEEX campaign as well. Yeah.
So that brings us to the end of this episode, and thank you so much, Dr. Thara. It was a delight. I mean, just to imagine, rolling through the clouds in an aircraft. I mean, that was wonderful.
Yeah.
Thank you once again for the time.
Thank you so much. Yeah.
That brings us to the end of today's conversation on cloud seeding, a technology that sits at the intersection of science, policy, and public imagination. As Delhi prepares for its first pilot trials, it is clear that weather modification cannot be viewed as a quick fix but rather as a complex scientific tool that requires calibration, long term research, and responsible governance. We are deeply grateful to Dr. Thara Prabhakaran for sharing her expertise and shedding light on the science behind cloud formation, rainfall enhancement, and the realities of artificial rain. Our thanks also go to Dr. Sulagna Chattopadhyay for steering this dialogue and drawing out the critical questions that link science with society. A detailed blog of this podcast is uploaded on www.geographynew.com. Do not forget to check it out, follow and subscribe for more. I'm your host Hiteshika, signing off.